So now we're looking at solving nonlinear systems of equations. And the technique is not so different than what we're used to. It's just that we are dealing with, combining maybe a linear equation with a conic section here and there. So if you kind of look at example 4, we've got ourselves a line. I know that from recognizing the equation. And then we do have ourselves y equals 2 minus x squared. That is a parabola because only one of the other terms are squared. Only the x term is squared. So that's what they mean by nonlinear. At least one of the equations is not linear. So that's where the parabola comes in. Now, they didn't specifically say the word analytically, but let me tell you, when it says give exact answers, that's what they want. That's just another word to say solve analytically. You'll notice once we go over solving graphically, it's impossible to get an exact answer. Usually it gives you an approximation. So we were kind of stuck if they want exact answers. So make sure you follow those directions. Be very, very detailed about that. Now, whenever you solve these nonlinear systems, keep in mind that you have a lot of options at your fingertips. You can use the elimination method, which we've been practicing a lot with systems of 3 equations and 3 variables. You could also use substitution if it kind of looks a little nicer for you. So that's actually what I'm kind of eyeing right now with example 4. I could do elimination as well. Maybe you want to try that on your own and see if we get the same answer. But I noticed that I'm already solved for y in the parabola version. So what I can do is I can take this 2 minus x squared and I could plug it back into the linear equation. So remember, when you are using substitution, you need to plug whatever you've solved for into the other equation, not itself. So I'll kind of label that for you. I am using substitution method. And I'm going to start off with x minus 3, but instead of y still equal to 6, I'm going to plug in 2 minus x squared. So if we do that, notice that we'd have to kind of clean up the left-hand side. If we do this, we would probably need to distribute the -3. So I should get x minus 6 plus 3x squared equals 6. And if we want to clean this up a little bit more, I'd like you to kind of even notice right now, you see that we have ourselves a quadratic equation. And why is it a quadratic equation? With all our experience from our previous chapters, you do see that we have an x squared going on. So now we get to incorporate the other different methods of how we would solve equations. In particularly a quadratic equation, it's probably useful for you to recognize it. Maybe I'll put this in order, descending order. I have 3x squared plus x minus 6 still equals 6. And with a quadratic equation, a lot of times it's useful to be able to move all of the terms on one side so that you have 0 on the other. Sometimes we can quickly factor a problem, and sometimes we can't. So what I'd like to double check, we can take a little time if we feel like factoring. We can kind of say, let's test it. So that might be quicker. I would say this is kind of the form ax squared plus bx plus c equals 0. So what we're trying to understand, a times c. So we have 3 times 12. What is that, 36? So we'd be looking at, factors of, negative 36. I'll write that a little nicer, sorry. That add up to 1. So a times c, factors of a times c that add up to b. Now, if we try to list all those factors of negative 36, I don't believe you can. what do we have? 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. You know, we're going to have opposite signs, but in no cases do we find the winning factors that make this true. So right away, we can determine that we can't factor it. So it's not factorable because we can't find it. And if something's not factorable, we have a few more options to take. You have your choice. I know my choice, but you can choose to complete the square in order to solve for x, or you can choose to use the quadratic formula. And you guess which one's my favorite? If you said quadratic formula, you were correct. So if it's not factorable, I am going to use that quadratic formula. So if that is using the quadratic formula, remember the solutions to the equation would be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if we know who a is and b and c, we just plug this in. So I'll try to be a little neater here. B is 1. So we have negative 1 plus or minus square root of 1 squared minus 4 times a is 3. And c is negative 12. So that's all over 2 times a, or 2 times 3. So we can simplify a little bit more. Negative 1 plus or minus square root of 1. Now 4 times 3 times 12. I'm going to kind of take the use of my calculator. That is a positive 144. That's going to be all over 6. Now that's too bad. It's not going to be a perfect square because in order for us to simplify, we have to add the items in the radicand first. So we actually have 145 all over 6. So that, my friends, we already know if you wanted to approximate square root of 145, you're not going to get a nice integer from this. So this would be the exact answers for x. That's the x values. If you wanted to, although I guess it matters depending on how far you take it, it's possible. Let's double check. I don't think 145 is going to be a nice product of a perfect square to number, but you could check. But they didn't really specify to simplify the exact answer as much as possible, so sometimes that's good enough. You want to make sure when you solve these, double check that, you know, sometimes we get so excited when we're done solving for x that we forget that we were also needing to solve this system. So what I'd like to show you is that before we find the y term, we have to actually plug in the x values. So if we do that, I will actually take a little time on this. So now if we found the exact answer for x, keep in mind when you have the plus or minus symbol, that plus or minus symbol, there we go. There's actually 2 values for x. So we split this up just a little bit. We have x equals negative 1 plus square root of 145 over 6, and x equals negative 1 minus square root of 145 over 6. Now, if we're needing to find the corresponding y values, we're going to look back to our equation involving the y. That's the other one. Y equals 2 minus x squared. So y equals 2 minus x squared. If we're going to find the corresponding y for each of our x's, we would need to plug our x values in. So we have 2 minus all the x values squared, negative 1 plus square root of 145 all over 6. The other one, y is equal to 2 minus, again, it's the x squared, and this is the corresponding x we would take. Negative 1 minus square root of 145 all over 6. So if you were to write your answers in ordered pairs, remember, you can't just circle them randomly and tell us x equals this, y equals this. We need to understand who the corresponding values are. So we need to see what those points are if you want to write your ordered pair or your actual solutions. I'll write this in blue. As an ordered pair, your x value, -1 plus square root of 145 all over 6, and 2 minus -1 plus square root of 145 all over 6 squared. That, my friends, is good enough for this y value, at least for the purposes of our course. Yes, you could multiply the binomial-like radical out and simplify a little bit more, but it's really not worth it at this point. So that's good enough. The other corresponding solution, just to make sure, we have -1 minus square root of 145 over 6, 2 minus -1 minus square root of 145 over 6 squared. And that, my friends, is an exact answer. That's good enough. This is why you're going to notice that you would use this if you're going to use calculations for something else later so that you don't run into any issues. But you might be interested in using your TI to see if you can verify what these solutions are. So we'll teach you that in the next example, and then see if you can resolve this system using your TI and see if you're getting kind of the same answers. So I hope this helps. I'll see you in the next example.